You think you know the universe. The truth is far stranger than you have been told. We are about to journey through 30 of the most bizarre cosmic secrets, from a galaxy with no dark matter to a star older than time itself. By the end of this, your perception of reality will be permanently altered. How can a vast region of space be almost completely empty? What kind of star dims so erratically it sparked talk of alien megastructures? What is the most unsettling cosmic mystery you have ever encountered? The first stop on our journey is a place of profound silence. We call it the Oddities void, but its nickname is far more evocative, the Great Nothing. Picture our observable universe as a vast, glittering web of galaxies, a cosmic metropolis teeming with light and structure. Now imagine a hole punched straight through it. This is the Oddities void, a spherical region of space so staggeringly empty it defies comprehension. It stretches for 330 million light-years across. To grasp that scale, if you placed our Milky Way at one edge, you would need to travel through near-total blackness for over 300 million years at the speed of light to reach the other side. In a volume of space that should contain thousands of galaxies, astronomers have found only a handful. It is a cosmic desert on a scale so grand it feels less like a feature of the universe and more like an error. Its very existence sent shockwaves through the field of cosmology. Our best models of the Big Bang and the formation of the cosmic web simply did not predict voids this immense. How could gravity, which pulls matter together, leave behind a vacancy so vast? It is as if you walked into a bustling city and found a district the size of a continent that was almost completely barren, just a few isolated houses standing in an ocean of empty lots. This great nothing is not just an absence, it is an active mystery, a silent question mark hanging in the dark. From the vast emptiness of the great nothing, we turn to a structure of impossible perfection. Hoag's object is a galaxy that seems to defy the very laws of chaos that govern the cosmos. Unlike our own spiral Milky Way or the messy ellipticals, this galaxy is a near-perfect ring. Picture a brilliant golden core of ancient yellow stars, a serene island floating in the black. Encircling it at a precise and vast distance is a flawless circle of young, hot blue stars, like a celestial halo or a piece of cosmic jewelry. Between them lies a deep, dark gap that appears almost completely empty. This is not the result of a camera trick or an optical illusion. It is the galaxy's true, bewildering form. The central mystery is its creation. Most ring galaxies form from violent head-on collisions where one galaxy punches through the center of another, sending shockwaves that trigger star formation in a ring. But Hoag's object shows no signs of a second galaxy, no debris or distortion that would point to such a catastrophic encounter. It exists in pristine, solitary splendor. How could such a symmetrical structure arise on its own? One compelling theory suggests it could be an extreme version of a polar ring galaxy, where a smaller galaxy was captured and torn apart, its stars forced into a perpendicular orbit around the larger core. Yet even this explanation feels inadequate for such a perfect circle. It stands as a silent, beautiful contradiction, a cosmic wheel whose origin remains one of the universe's most elegant puzzles. From celestial perfection, we plunge into a nebula of startling geometry. The Red Rectangle Nebula is a structure so angular it looks engineered. Far from the chaotic clouds of most stellar nurseries, this object presents a near-symmetrical X-shape, a pair of intersecting lines that form a hollow, rectangular frame glowing with a deep crimson light. This is not a trick of perspective, it is the nebula's true form, a stark contrast to the organic swirls we typically see in the cosmos. At the heart of this geometric wonder lies a binary star system, two stars locked in a tight orbital dance. It is from this dynamic relationship that the strange shape emerges. The leading theory suggests that as these stars age, they are shedding their outer layers, but instead of blowing them away in a uniform sphere, they are funneling the gas and dust into two opposing cones. From our vantage point on Earth, we are looking directly down the barrel of this double cone structure. The dark band that forms the rectangle's hollow center is the thick waste of dust where the cones meet, while the glowing red sides are the illuminated walls of the cones themselves. That intense red color comes from a specific type of molecule, luminescent hydrocarbons. These are not just pretty lights, they are complex carbon-based compounds, the very building blocks of more complex organic matter. The red rectangle is essentially a cosmic factory, forging the precursors to the ingredients for life and spraying them out into the void in a display of breathtaking mathematical beauty. But the universe does not only build, it also preserves. Locked away in a distant corner of space is a cosmic time capsule, a galaxy called NGC 1277. Unlike the vibrant, evolving galaxies we are used to, this one is a relic, a fossil frozen in time. It has not formed any significant number of new stars for over 10 billion years. To put that into perspective, when this galaxy went dormant, our own Sun and Earth had not even been born. It is a pristine snapshot of the early universe, a celestial museum piece that has somehow avoided the chaos that shapes everything else. Our current understanding tells us that large galaxies grow by cannibalizing their smaller neighbors. They gravitationally tear them apart, absorbing their stars and gas, a violent process that triggers new rounds of star formation and constantly rejuvenates the galactic system. This is the natural life cycle, a cosmic food chain where the biggest galaxies feast to become even larger. Yet NGC 1277 has refused to dine. It has remained isolated, aloof, and untouched by the mergers that should have transformed it. How did it evade this fundamental process for so long? Its sheer stillness is a profound oddity, challenging the very narrative of how galaxies are supposed to live and grow. It forces us to ask if we have misunderstood the rules of the cosmic game, presenting a ghost from the past that has simply stopped playing. From the silent fossil of a galaxy, we arrive at a world of unimaginable opulence and fury. 55 Cancri E is a planet that should not exist, a jewel forged in a stellar inferno. Orbiting perilously close to its sun, this world completes a full year in just 18 hours. Its surface is a blistering hellscape with temperatures soaring high enough to liquefy iron and turn rock into molten slag. Yet beneath this incandescent violence lies its true secret. Astronomers believe this planet is not made of rock and iron like Earth, but is predominantly carbon. In the unimaginable pressures of its interior, that carbon is likely compressed into crystalline structures, meaning this entire world could be, for all intents and purposes, a planet-sized diamond. Its very existence suggests it was born from a star system that was extraordinarily rich in carbon, the ashes of a star that provided the raw material for such a bizarre gem. The discovery of 55 Cancri E fundamentally rewrites the rules of planetary formation. We thought we understood the basic ingredients for building worlds, but a diamond planet challenges every assumption. It opens up a universe of possibilities where planets could be made of substances we once considered science fiction. While the prospect of mining such a world remains a fantastical dream, its reality forces us to wonder what other impossible treasures are waiting in the dark, each one a testament to the universe's limitless and violent creativity. While we grapple with the idea of a diamond world, a new and entirely different mystery has emerged from the static of deep space. Astronomers recently stumbled upon something they could not immediately explain: enormous faint circles of light imprinted on radio telescope data. They called them odd radio circles, or ORC, a name that reflects their complete and utter strangeness. These are not planets or stars, they are colossal structures, often larger than entire galaxies, and they exist only in the radio spectrum. If you were to look at the same patch of sky with an optical telescope, you would see nothing at all. No visible light, no X-rays, just empty space. It is as if someone has drawn glowing rings on the fabric of the cosmos with a kind of invisible ink. The leading theory suggests these could be the aftermath of a titanic event, perhaps a shock wave from a powerful starburst that rippled out across intergalactic space. Another, far more speculative idea posits that we might be looking at the throats of wormholes, the theoretical tunnels through space-time. What makes the ORCs so deeply unsettling is their sheer novelty. They represent a class of object we never knew existed, reminding us that our maps of the universe are still woefully incomplete, and that the greatest discoveries are often the ones we never thought to look for. The cosmos is not static, and even our own galaxy is not adrift. We are all moving, pulled by an unseen hand toward a point in the darkness known as the Great Attractor. This is a gravitational anomaly of staggering power, a focal point in intergalactic space that is drawing our Milky Way, the Andromeda Galaxy, and thousands of others in our local galactic neighborhood on a relentless journey we cannot escape. For decades, this force was a profound embarrassment to astronomers. They could measure our motion, they could feel the pull, but they could not see what was causing it. The Great Attractor lies in the direction of the constellation Norma, a region directly behind the plane of our own galaxy. This area is what astronomers call the zone of avoidance. It is a place where the thick dust, gas, and countless stars of the Milky Way's central bulge create an impenetrable wall, blotting out the visible light from the universe beyond. It was like trying to find the source of a siren's call from deep within a dense, blinding fog. How could we map a mystery we could not even see? The breakthrough came when we learned to listen with different ears, using radio, X-ray, and infrared telescopes that could pierce through the cosmic smog. What they revealed was not a single, monstrous object, not a cosmic vacuum cleaner as some had imagined. Instead, the Great Attractor is a confluence, a grand gathering of mass on a scale that is difficult to grasp. It is a gravitational focal point created by the combined pull of several enormous galaxy clusters, most notably the Norma cluster, all concentrated in one region of space. Think of it not as a giant magnet, but as the deepest part of a universal valley, a dip in the fabric of space-time so profound that everything for hundreds of millions of light years is slowly, inevitably rolling down its slopes. We are not being hunted, we are simply flowing with the cosmic current, drawn toward the greatest concentration of mass in our corner of the universe. This cosmic current pulls us toward an enigma that flickers in the night, a star that simply refuses to behave. KIC 8462852, better known as Tabby's star, is a cosmic rebel whose light does not follow any of the established rules. Most stars exhibit tiny, regular dips in brightness when planets pass in front of them, a predictable rhythm astronomers rely on to discover new worlds. But Tabby's star is different. Its light dims erratically and dramatically, sometimes by as much as 22%, a drop far too severe to be caused by any planet. It is as if a swarm of enormous, shapeless objects were drifting in front of it in a chaotic, unpredictable dance, blocking its light for days or even weeks at a time. The data was so bizarre that when astronomers first saw it, they assumed it was a glitch in the Kepler Space Telescope's instrumentation. But the signal was real and it demanded an explanation. The theories that emerged were as wild as the data itself. Some suggested a colossal swarm of comets shattered by a close encounter with the star, creating a vast, irregular cloud of ice and dust. Others, however, dared to voice a more extraordinary possibility. Could we be witnessing the construction of an alien megastructure, a Dyson sphere in its early stages of assembly, a vast network of solar collectors built by an advanced civilization to harness the entire energy output of their sun? This idea, while speculative, captured the public imagination and turned Tabby's star into a global sensation. What followed was a remarkable collaboration. Professional astronomers, lacking the telescope time to monitor the star continuously, turned to the public for help. A Kickstarter campaign raised over $100,000, allowing scientists to purchase time on a global network of telescopes. Thousands of citizen scientists pored over the data, looking for patterns in the star's bizarre behavior. This collective effort has ruled out some of the simpler explanations. The dimming is not caused by a single large object, and the star's long-term, slight fading over a century makes a simple comet swarm seem less likely. Yet a definitive answer remains elusive. The mystery of Tabby's star endures, a stark reminder that some of the universe's most compelling puzzles are not just about what we can see, but about what we are forced to imagine. The universe harbors relationships of cosmic horror, and few are more vicious than the Black Widow pulsar. This is not a simple dance of two stars, but a slow, methodical execution. At its heart is a pulsar, the ultra-dense, rapidly spinning corpse of a massive star. It rotates hundreds of times every second, and with each revolution it sweeps the space around it with a lighthouse-like beam of intense radiation and a hurricane of high-energy particles. This relentless assault is directed at its companion, a small, doomed star locked in a tight, 3-hour orbit. The pulsar's energy is so ferocious that it is literally cooking and evaporating its partner, stripping away the star's outer layers atom by atom. Astronomers can actually observe this stellar murder in progress, seeing a vast, shimmering cloud of vaporized material being blown away from the smaller star by the pulsar's wind. This process has left the companion star burned down to a fraction of its original mass, a charred cinder being relentlessly ablated by its predator. The pulsar will not stop until it has completely consumed its partner, leaving behind nothing but an isolated remnant of its crime. This celestial predation offers a stark lesson in the dynamics of binary systems, where the gravitational bond between two objects can become a death sentence. It is a dramatic, real-time demonstration of how the universe can forge the most extreme environments, turning stellar companions into nothing more than cosmic prey. The predatory dance of the Black Widow pulsar shows the universe can be ruthlessly efficient, but some cosmic arrangements are bafflingly empty. NGC 1052DF2 is a galaxy that defies the most fundamental rule of cosmic architecture. For decades, our entire understanding of how galaxies hold themselves together has rested on a single, invisible substance, dark matter. We believe this mysterious material forms a vast, heavy halo around every galaxy, its immense gravitational grip preventing stars from flying off into the void. It is the hidden skeleton of the cosmos, the cosmic glue, and then we found a galaxy seemingly built without it. NGC 1052DF2 is a ghostly, diffuse galaxy, a wispy collection of stars so spread out you can almost see right through it. When astronomers measured the motions of its bright globular clusters, they expected to see them whizzing around at high speed, pulled by the powerful gravity of an unseen dark matter halo. Instead, they found the clusters moving at a leisurely, almost sluggish pace. The math was inescapable. The total mass calculated from their motion was almost exactly equal to the mass of the visible stars themselves. There was simply no room left for dark matter. This was like watching a handful of pebbles orbiting a bowling ball, and discovering their speed perfectly matches the bowling ball's own gravity, with no hidden lead weights required. The discovery sent shockwaves through cosmology. How could a galaxy form without the very ingredient we thought was essential for gathering matter in the first place? It challenged the standard model at its core. The debates were immediate and fierce. Some suggested it was the result of a violent encounter, that a cataclysmic event had ripped away its dark matter. Others questioned the measurements themselves or the galaxy's true distance. Yet the search for similar anomalies only confirmed the strangeness. More of these dark matter-deficient galaxies have since been found, forming a new class of cosmic oddity that forces us to reconsider everything. Perhaps dark matter is not as universally attached to galaxies as we assumed, or maybe the universe has more than one way to build an island of stars. This impossible galaxy stands as a profound challenge, a cosmic rebel that proves we are still missing a critical piece of the puzzle. This is a star with a violent past and a dramatic present. Zeta Ophiuchi is a stellar behemoth, a blue giant 20 times more massive than our Sun, and it is not staying still. It is racing through a cloud of interstellar dust at a staggering speed of 100,000 miles per hour. At that velocity, you could travel from Earth to the Moon in under 4 seconds, but its speed is only half the story. As this runaway star plows through the cosmos, it acts like a cosmic speedboat pushing a vast wave of material ahead of it. The result is a spectacular bow shock, a brilliant arc of compressed and heated gas and dust that glows with intense energy. In visualizations, it appears as a perfect wave curling around the star, a luminous, rippling wall in space. How does a star achieve such an incredible velocity? It was not born this way, it was thrown. The leading theory is a tale of cosmic betrayal and destruction. Astronomers believe Zeta Ophiuchi was once part of a binary system, gravitationally bound to an even more massive partner. That partner, living a short and furious life, reached its end and exploded in a cataclysmic supernova. The explosion would have been so violent that it instantly blasted the binary bond apart, flinging the surviving star, Zeta Ophiuchi, away from the wreckage like a stone from a sling. The star was given a permanent kick, sent flying across the galaxy on a solitary, high-speed journey. The beautiful bow shock we see is the permanent scar of that escape, the visible evidence of its headlong flight through the delicate medium of space. We are witnessing the aftermath of a stellar catastrophe, a ghost from a binary system that no longer exists, forever running from the sight of its companion's death. Deep within the chaotic heart of our galaxy, a new class of ancient stars has been found, behaving in a way that no one predicted. They are called old smokers, and their existence rewrites the final chapters of a star's life. These are red giants, immense and aging, located in the crowded central bulge of the Milky Way. For decades, they can sit in perfect silence, appearing stable and unremarkable. Then, without any warning, they suddenly begin to dim, fading so dramatically that they almost vanish from view. What is happening is not a simple flicker, but a profound internal upheaval. Astronomers now believe these stars are literally coughing, expelling colossal clouds of smoke like dust that shroud them from sight. Imagine a gentle giant sitting quietly in a room who suddenly exhales a cloud of smoke so dense it completely obscures them. These are not violent explosions like supernova, but slow, convulsive eruptions that last for years. The significance of this strange behavior is staggering. These old smokers are likely cosmic recyclers on a grand scale. During their long, quiet lives, they have been forging heavy elements deep within their cores, elements like carbon, iron, and oxygen, the very building blocks of planets and life itself. With each great cough, they blast these newly forged materials out into the interstellar void, seeding the surrounding gas clouds with the ingredients for future generations of stars, planets, and perhaps even living organisms. For years, astronomers wondered how these crucial elements were so effectively distributed throughout the galaxy. The answer may have been hiding in plain sight, in the form of these seemingly placid, elderly stars that occasionally puff vast clouds of cosmic soot into the galactic winds. Sometimes the most colossal discoveries begin as a ghost. While astronomers were studying the light from a brilliant, distant quasar, they noticed something strange. Its light was being absorbed in a peculiar way, as if it were passing through an enormous, invisible cloud of cold gas. This was not a random wisp of interstellar matter. It was the distinct shadow of a galaxy, a silhouette cast against the cosmic backdrop. They had found the Cosmic Yeti, a monster galaxy from the dawn of time, not by seeing its light, but by seeing the shadow it left upon the light of another. For years, such galaxies were only theoretical predictions, giants that were thought to have formed in the universe's chaotic infancy. They were the cosmic equivalent of mythical beasts rumored to exist but never seen. The Yeti proved they were real. This was a behemoth forming stars at a rate 100 times faster than our own Milky Way, a frantic, explosive period of creation when the universe was only about 1 billion years old. Its existence is a direct challenge to our models of cosmic evolution. We thought galaxies grew slowly, steadily accumulating mass over billions of years through mergers. But the Yeti suggests some galaxies were born as titans, forming in a sudden, violent collapse of primordial gas. It forces us to rewrite the early chapters of galactic history, proving that the universe's first giants were not just myths but shadows waiting to be found. The Methuselah star presents a paradox that nearly broke cosmology. Known formally as HD 140283, this ancient sun lies within our own galaxy, a mere 200 light-years away. When astronomers first measured its age, the result was nothing short of terrifying. Their calculations suggested the star was 16 billion years old, a number that directly contradicted the age of the universe itself, which is estimated at 13.8 billion years. How could a star be older than the cosmos that birthed it? The answer lies in the delicate art of stellar dating. Astronomers determine a star's age primarily by its chemical composition. The very first stars to form after the Big Bang were composed almost entirely of hydrogen and helium, the primordial elements forged in the universe's first moments. They lived fast, died young, and in their spectacular supernova deaths, they created and scattered heavier elements like oxygen and iron across the cosmos. Subsequent generations of stars were born from this enriched material. The Methuselah star has an extremely low metal content, placing it firmly in that second generation. By measuring its precise ratios of elements and then plugging that data into models of how stars burn their nuclear fuel over time, scientists can estimate when it must have ignited. The initial result pointed to a birth date that preceded the Big Bang. This was an impossible conclusion. It forced a profound re-examination of both the stellar models and the cosmological measurements. The solution came from a more precise reading of the star's distance gathered by the Hubble Space Telescope. A slight adjustment in its position revealed it was slightly brighter and therefore slightly closer than previously thought. A brighter star burns its fuel faster, meaning it has a shorter lifespan. This crucial correction, combined with refined models that accounted for the star's internal mixing processes, brought its estimated age down to around 14.5 billion years. This figure, while still staggeringly old, now falls just within the margin of error for the universe's age. It remains an extreme outlier, a relic that pushes our understanding of stellar physics to its absolute limit. The Methuselah star is a perpetual warning, a cosmic elder that reminds us our best models are still approximations and that the universe always holds a deeper truth. Even the Great Attractor cannot fully explain the motion of our entire galactic neighborhood. There is another, far more controversial current pulling at the fabric of the cosmos, a phenomenon so unsettling it is known as the dark flow. By studying the subtle, leftover glow from the Big Bang, the cosmic microwave background, astronomers made a bizarre discovery. They found that entire clusters of galaxies, numbering in the thousands, are not just drifting randomly. They appear to be moving in a coherent stream, all being pulled in the same specific direction, as if by a cosmic tide. This is not the local pull of the Great Attractor, but a motion on a scale so vast it defies conventional explanation. The source of this gravitational pull seems to lie far beyond the edge of our observable universe. Imagine standing on a shore and seeing every river, every current, flowing relentlessly toward a single, unseen point on a distant, invisible horizon. That is the implication of the dark flow. Our entire observable cosmos, nearly 100 billion light-years across, might be just one island in a much grander archipelago, and we are feeling the gravitational tug of a neighboring island so immense we can never hope to see it. This idea sparked a firestorm in the scientific community. Proponents argued this could be the first indirect evidence for the multiverse, a sign that other universes beyond our own are exerting a real physical force on us. Skeptics, however, countered fiercely, suggesting the data was a statistical fluke or the result of local effects not properly accounted for. The debate raged for years, a battle over the interpretation of the universe's most ancient light. While subsequent studies have cast doubt on the original findings, the concept of the dark flow remains a tantalizing, if unproven, ghost in the data. It forces us to confront a humbling possibility that the greatest forces shaping our cosmic journey may originate from realms we are fundamentally forbidden from observing. While entire galaxies drift on cosmic currents, a storm of impossible geometry rages much closer to home. At Saturn's North Pole, a perfect hexagon larger than Earth has been etched into the atmosphere. This is not a fleeting cloud formation. It is a permanent, six-sided jet stream that has endured for decades, a feature with no equal anywhere else in our solar system. Each side is longer than the diameter of our entire planet, and the entire structure rotates with a clockwork precision, completing one revolution roughly every 10 hours and 39 minutes. At its very center spins a massive, rotating storm, a colossal hurricane-like vortex. This stark geometric perfection stands in shocking contrast to the planet's south pole, which hosts a more conventional, though still immense, circular vortex. Why would one pole of a gas giant obey the normal rules of fluid dynamics while the other defies them with such rigid, angular beauty? The leading explanation dives into the physics of standing waves. Think of the hexagon as a persistent, stable vibration in Saturn's atmosphere, like a note held on a vibrating string. Laboratory experiments have shown that when a fluid rotates at different speeds at its center and its edges, it can sometimes settle into polygonal shapes. On Saturn, deep-rooted jet streams might be acting as wave guides, channeling the atmospheric flow into this specific six-sided pattern. It is a natural, if extraordinarily rare, resonance, a harmonic of the planet's own rotation made visible on a planetary scale. This celestial hexagon is a breathtaking demonstration that nature's laws can produce art of staggering precision, a reminder that even within the swirling chaos of a gas giant's atmosphere, an unseen order can prevail. The universe holds detonations so swift and fierce they last only a few thousandths of a second. We call them fast radio bursts, and one of the most compelling explanations for their origin is a theoretical cataclysm known as the Blitzar. This event begins with a zombie star, a neutron star that has cheated death. Neutron stars are the unimaginably dense corpses of massive stars, so compressed that a single teaspoon of their material would weigh billions of tons. Some of these stellar corpses are born spinning at incredible speeds, and this rapid rotation, combined with their immense density, provides an outward force that fights against the relentless pull of their own gravity. It is a cosmic balancing act, a temporary stalemate between spin and collapse. For millions of years, this neutron star can exist in this precarious state. But it is slowly losing the battle. It emits energy in the form of radiation and particles, a process that gradually bleeds away its rotational speed. Like a spinning top finally beginning to wobble, the star's defenses weaken. The moment its spin slows beyond a critical threshold, gravity wins. In an instant, the entire structure gives way, collapsing into a black hole. The event horizon, the point of no return, forms at the star's core and spreads outward at the speed of light. As this boundary slices through the star's incredibly powerful magnetic field, it does something extraordinary. The magnetic field lines anchored to the star's surface are suddenly severed. This violent disconnection unleashes a titanic shockwave of energy, a final, brilliant scream that ripples across the universe as a fast radio burst. The entire event, from collapse to emission, is over in less time than it takes you to blink. The blitzar is a ghost, a one-time event that leaves behind only a silent black hole and a fleeting, enigmatic signal that challenges our perception of stellar death. Some cosmic explosions do not just break the rules, they detonate in places where no star should be. This is the story of supernova 2016 IET, a stellar cataclysm that occurred in the profound emptiness of intergalactic space. It was a star that lived and died in complete isolation, far from the nurturing gas clouds of any galaxy. For 2 years, this supernova remained bright, a duration far longer than any ordinary stellar explosion. Its light curve was strange and its spectrum utterly alien, lacking the hydrogen and helium common in most supernova, yet glowing with strong lines of calcium and oxygen. The energy required for such a long, brilliant display was staggering, pointing to an explosion of almost unimaginable violence. The evidence points toward a pair instability supernova, a theoretical class of event so powerful it was thought to have existed only in the universe's earliest chapters. This occurs in stars of truly monstrous size, those with masses between 150 and 250 times that of our Sun. In their cores, the intense heat and pressure begin to spawn pairs of electrons and their antimatter counterparts, positrons. This process saps the radiation pressure that was holding the star up against its own gravity. Without that outward push, the core collapses in an instant, triggering a runaway thermonuclear explosion that does not leave behind a black hole or neutron star, but utterly obliterates the entire star, scattering its guts across the cosmos. SN 2016 IET was the death cry of one of these primordial giants, a star that belonged to the first generation of the universe. Its isolated location is the deepest part of the mystery. How could a star over 200 solar masses form in the cosmic boondocks without the dense, rich environment of a galactic core or a bustling stellar nursery? It suggests that pockets of pristine gas from the early universe may have survived, collapsing in splendid isolation to forge these rare, magnificent beasts. This lonely supernova forces us to redraw the map of star formation, proving that the universe can create its most spectacular fireworks in the quietest, most forgotten corners of the void. The star epoch 204278916 presents a dimming pattern even more extreme than Tabby's star. This young, sun-like star is only about 5 million years old, still surrounded by a thick, rotating disk of gas and dust, the raw material from which planets are born. Yet its light tells a story of profound and irregular shadow. Over a 78-day observation period by the Kepler Space Telescope, its brightness suddenly plummeted by a staggering 65%, an eclipse so deep it suggests something colossal was drifting between the star and us. This was not a brief flicker, but an event that lasted for an entire 25 consecutive days. The scale of the obstruction required to cause such a deep, prolonged dimming is almost incomprehensible. To block that much light, the object must be wider than the star itself, a structure of staggering proportions. One of the leading natural explanations points to the star's youth. Its circumstellar disk could be warped or tilted, and within it, massive clouds of planetary building blocks or swarms of giant, melting comets on highly eccentric orbits could be passing in front of the star, casting these immense shadows. The sheer amount of material required, however, pushes the limits of what we believe is possible in a young solar system. The extreme nature of the data inevitably led to the same tantalizing question raised by Tabby's star. Could this be evidence of a Dyson sphere under construction, a colossal array of energy collectors being assembled by an advanced civilization in this infant star system? While most astronomers strongly favor natural, if extraordinary, astrophysical explanations, the sheer depth of the dimming leaves a sliver of room for the imagination. This young star's dramatic flickers serve as a powerful reminder that the universe is capable of producing shadows we do not yet fully understand. and that the line between a natural marvel and an artificial one remains provocatively thin. That young star's deep shadow is a temporary mystery, but another kind of cosmic phantom leaves a permanent mark. Far beyond our local stars, astronomers have detected a true ghost, a vast and faint cloud of X-ray emission enveloping an entire distant galaxy. This is not a cloud of dust or gas as we normally understand it. It is a shimmering, invisible to the human eye shroud of high-energy radiation. The source of this eerie glow is the central mystery. There is no active quasar blazing at the galaxy's heart, no obvious, ongoing cataclysm to explain why this immense volume of space is filled with such energetic light. The leading theory is that we are looking at a cosmic echo, the fossil record of a tantrum thrown by the galaxy's supermassive black hole in the distant past. Billions of years ago, this black hole would have been in an active feeding frenzy, pulling in colossal amounts of matter. As that material spiraled into the abyss, it grew intensely hot and bright, launching titanic jets of energy and particles that blasted out into intergalactic space. This outburst would have heated the surrounding gas to millions of degrees, causing it to glow in X-rays. Then the feast ended. The black hole ran out of nearby fuel and fell quiet, its brilliant active nucleus shutting down. But the immense cloud of superheated gas it created did not instantly vanish. It has been slowly cooling and fading over billions of years, a dying ember from a forgotten fire. This X-ray ghost is a celestial palimpsest, a faded text telling the story of a violent, bygone era. By studying these phantoms, astronomers can piece together the life cycles of galaxies and their hidden black hole hearts. It reveals that a galaxy's quiet, stable present can be a mask hiding a ferociously active youth. How many other seemingly placid galaxies are merely sleeping giants, surrounded by the faint, glowing ghosts of their own past fury? The universe has a pulse. In the vast quiet between the stars, astronomers have detected a rhythmic flicker so precise it mirrors the beating of a human heart. These are the heartbeat stars, binary systems locked in a gravitational dance of breathtaking intimacy and regularity. Unlike the erratic dimming of Tabby's star, their light curves trace out a clean, repeating pattern of peaks and valleys, a cosmic electrocardiogram broadcast across the light years. The source of this rhythm is not a swarm of comets or a mysterious structure, but the stars themselves caught in an embrace of immense force. Their orbits are not neat circles, but highly elongated ellipses. For most of their orbit, they are distant, cool, and calm. But as they swing toward their closest approach, their mutual gravitational pull becomes overwhelming. Each star stretches the other, pulling their atmospheres into tidal bulges, distorting their spherical forms into egg-like shapes. This dramatic contortion causes their combined brightness to surge, creating the peak of the heartbeat. As they swing apart, they relax back into spheres, and the light dips, completing the cycle. This celestial pulse does more than create a beautiful light show. It provides astrophysicists with an unparalleled laboratory. By precisely timing the heartbeat and measuring the depth of the dips, scientists can calculate the stars' masses, sizes, and even their internal densities with extraordinary accuracy. It is like being able to weigh and measure two distant objects simply by observing the rhythm of their dance. These systems reveal the hidden complexities of stellar interiors and the subtle ways gravity can bend and shape massive bodies. Each heartbeat is a conversation written in light, a direct transmission of the fundamental forces choreographing the cosmos. The universe's steady pulse was suddenly interrupted by a visitor from another star. In October 2017, astronomers in Hawaii spotted a strange object moving at blistering speed, the first confirmed tourist from interstellar space. They named it Oumuamua, a Hawaiian word meaning scout or messenger from the distant past. This was no ordinary asteroid or comet. It was an alien in the purest sense, born around a star we will never know. Its trajectory was hyperbolic, meaning it was not bound by the sun's gravity. It was just passing through our system on a one-way journey into the unknown. But its physical characteristics were what truly defied explanation. First was its shape. Based on how its brightness changed dramatically as it tumbled, Oumuamua appeared to be profoundly elongated, perhaps 10 times longer than it was wide. This cigar-like form is unlike any asteroid or comet we have seen in our own solar system, where objects tend to be more lumpy and rounded. Then came the real puzzle, its acceleration. As Oumuamua sped away from the sun, it was not just following a gravitational path. It was speeding up slightly, as if pushed by an unseen force. Comets often exhibit non-gravitational acceleration when sunlight vaporizes their icy surfaces, creating a jet of gas that acts like a tiny rocket engine. This process also forms a visible atmosphere called a coma and often a tail. Yet Oumuamua displayed no coma, no tail, no visible outgassing whatsoever. It was a dark, silent rock behaving like a comet in secret. The scientific community erupted in a fierce debate to explain these contradictions. One camp proposed it was a fractal dust aggregate, a cosmic dust bunny of incredible porosity that could have been ejected from a distant stellar system. This fragile structure could explain the acceleration, as trapped gases leaking from its icy interior would not need to form a visible cloud. Others suggested it was a shard from a planet that was torn apart by its star's gravity, a piece of cosmic shrapnel that naturally formed an elongated shape. The most famous and controversial hypothesis came from Harvard astronomer Avi Loeb, who posited that Oumuamua could be a piece of alien technology, a light sail or a derelict probe designed to travel between stars, its flat, thin shape accounting for the strange acceleration as it was pushed by the radiation pressure from sunlight. While most astronomers favor a natural origin, the true nature of Oumuamua remains an open question. Its lasting legacy is not a definitive answer, but a profound shift in our perspective. It proved that interstellar objects are constantly drifting through our cosmic neighborhood, opening an entirely new field of study. We are no longer isolated. We are simply a port of call for silent, mysterious travelers from the galactic dark. While interstellar travelers like Oumuamua capture our imagination, the cosmos holds structures far more fundamental and elusive. AGC 229385 is a ghost, a candidate for what astronomers call a dark galaxy. This is not a galaxy as we know it, not a brilliant pinwheel of stars, but a massive clump of dark matter that appears to have almost no stars at all. It was discovered not by the light it emits, but by the silent radio whispers of its neutral hydrogen gas. Vast clouds of this primordial material were detected spinning within an invisible gravitational grip, a clear sign that a massive, unseen structure was holding it together. Yet when optical telescopes turned to look, they found only profound darkness, a void where a galaxy should be. The sheer mass implied by the hydrogen's motion is immense, but the amount of visible matter, the stars we can see, is negligible. This presents a cosmic riddle. Is this a failed galaxy, a pocket of the early universe where the gas was too turbulent or too isolated to collapse and ignite into stars, leaving behind a barren island of dark matter? Or are dark galaxies like this one a common, previously invisible component of the cosmic web, the hidden scaffolding upon which the brilliant galaxies we see are built? Their existence could explain where a significant portion of the universe's dark matter has been hiding, not spread thinly, but gathered into these invisible archipelagos. Finding more of these phantoms would force us to redraw our maps of the universe, revealing a hidden landscape of mass that has been there all along, just beyond the reach of our eyes. Even our most iconic cosmic landmarks are not what they seem. The pillars of creation captured in that breathtaking Hubble image have long symbolized the majestic and enduring nature of stellar birth. Those towering, dark columns of dust and gas silhouetted against a glowing nebula felt like permanent cathedrals in the cosmos, but the James Webb Space Telescope has peeled back the veil, and the new view is one of both creation and destruction. Webb's infrared eyes see straight through the opaque dust that Hubble could not penetrate. Inside the pillars, we no longer see just shadowy forms. We see the brilliant points of light from infant stars still swaddled in their natal gas. They are the very engines of the pillar's own demise. These young stars are firing off intense ultraviolet radiation and powerful stellar winds, which are actively boiling away the surrounding material, sculpting the pillars even as we watch. The elegant spires are not serene monuments, they are temporary, eroding butts in a cosmic desert storm. This is a snapshot of a violent, ongoing process. The very material that gives these pillars their form is the same material that is feeding the young stars whose energy is now disassembling them. It is a beautiful, self-consuming cycle, a reminder that in the universe there is no true stillness, only change measured on a scale so vast we mistake it for permanence. Our own planet is now the source of a new and rapidly evolving cosmic phenomenon. The pristine darkness of the night sky, a canvas for astronomers and dreamers for all of human history, is being fundamentally altered. We are now witnessing the rise of mega-constellations, vast networks of thousands of communication satellites launched into low Earth orbit. These silent, metallic flocks are designed to beam the internet to every corner of the globe, but they come with a profound and unintended consequence for our view of the cosmos. To a ground-based telescope, each satellite is a moving point of reflected sunlight, streaking across long exposure images of distant galaxies and nebulae. What was once a clean, deep portrait of the universe is now being slashed by these brilliant, artificial trails. They are not just a minor annoyance, they are a form of light pollution on a global scale, effectively vandalizing our astronomical data. The problem extends beyond visible light. These satellites broadcast and receive radio signals, and their transmissions are beginning to bleed into the sensitive frequencies used by radio telescopes. It is like trying to listen for a whisper in a library while a constant, loud conversation is happening just outside the door. This human-made oddity forces a difficult question about our relationship with the cosmos. Are we so focused on connecting our own world that we are willing to sever our connection to the universe beyond? We are creating a legacy for future generations, one where the natural night sky is a memory replaced by a swarm of our own creation. This is not a mystery from the depths of space, but one of our own making, and the solution will require a new kind of cosmic balance. This faint chill on the cosmic background radiation is one of the universe's most persistent and profound mysteries. Known simply as the cold spot, it is a vast circular region in the afterglow of the Big Bang that is significantly colder than its surroundings. This is not a tiny blemish, but a colossal patch of sky, nearly 1 billion light-years across, where the primordial glow is just a fraction of a degree cooler. At first, scientists thought it might be a statistical fluke, a random ripple in the data. But as our maps of the cosmic microwave background grew more and more precise, the cold spot remained a stubborn and undeniable anomaly. The most straightforward explanation pointed to a supervoid, an enormous region of space with far fewer galaxies and galaxy clusters than average. Light traveling through such a void would lose a tiny amount of energy as it climbs out of the void's weakened gravitational field, an effect known as the integrated Sachs-Wolf effect. It would be like a cyclist having to pedal uphill out of a vast, shallow valley, arriving on the other side with slightly less energy. Astronomers scrambled to find this proposed supervoid. They surveyed the region, counting galaxies, and they did find a void, but it was not nearly large enough or empty enough to account for the profound coldness of the spot. The numbers simply did not add up. The void was there, but it was too shallow to create such a deep cosmic chill. This mismatch forced cosmologists to consider far more exotic possibilities. One of the most mind-bending theories suggests that the cold spot is a bruise, a cosmic scar left from a collision with another universe. In certain multiverse models, our universe is one bubble in a frothing sea of space-time foam, and these bubbles can occasionally bump into each other. If a neighboring universe grazed ours in the first instance after the Big Bang, the energy drained from that contact could have left a permanent cold imprint on our cosmic background. Another idea posits that the cold spot is a texture, a topological defect in the fabric of spacetime left over from the universe's rapid expansion. Think of it as a cosmic knot that formed when the fundamental forces of the universe froze into their current state, a region of tangled spacetime that subtly alters the passage of light. Yet these extraordinary explanations remain in the realm of theory. The cold spot endures as a silent, chilling enigma. It is a reminder that our most detailed map of the infant universe still contains features we cannot explain, hints that the true nature of reality might be stranger than any void or bubble we have yet conceived. That faint chill on the cosmic background is a whisper compared to the cosmic scream that once ripped through our solar system. In 2004, a wave of energy of almost unimaginable power washed over Earth, a blast so fierce it actually compressed our planet's magnetic field and violently ionized the upper atmosphere. The source was not the Sun, but an object in a galaxy 11.4 million light-years away. This was a giant flare from a magnetar, a cosmic event of such staggering violence it briefly outshone its entire host galaxy. A magnetar is a neutron star pushed to an even more extreme. It is the collapsed core of a massive star, but one born spinning at an incredible rate and endowed with the most powerful magnetic field in the universe. To grasp its strength, consider a typical refrigerator magnet. It has a field of about 100 Gauss. The magnetar that flared possesses a field of approximately 1,000 trillion Gauss. If one were to come even halfway between the Earth and the Moon, its magnetic pull would be strong enough to strip the information from every credit card on the planet. These objects are so unimaginably dense that a single sugar cube-sized piece of one would weigh more than 1 billion tons, the weight of every human on Earth combined. The giant flare itself is thought to be a starquake, a catastrophic rupture of the magnetar's rigid crust. As the star's immensely powerful magnetic field slowly twists and evolves over time, it places unimaginable stress on the neutron star's surface. This crust, a lattice of iron nuclei 10 billion times stronger than steel, cannot withstand the strain forever. It suddenly fractures, releasing more energy in 1/10 of a second than our Sun will emit in 100,000 years. The resulting explosion unleashes a firestorm of gamma rays and X-rays, a pulse of pure energy that can cross intergalactic space and still leave a mark on a world millions of light-years away. For that brief moment, that distant magnetar was the brightest object in the gamma-ray sky, a single stellar corpse briefly outshining every quasar, every supernova in the observable universe. It stands as a terrifying reminder of the raw, untamed power that sleeps in the hearts of dead stars. Far beyond the known planets, a ghost is tugging at the edges of our solar system. The evidence for this phantom world, known only as Planet 9, is written not in light but in the silent, looping paths of icy bodies in the dark. Astronomers studying the most distant objects in our solar system, the trans-Neptunian objects, found something deeply strange. The orbits of a specific group of these icy remnants are not randomly oriented. Instead, their elongated paths are clustered together, their closest approaches to the Sun all pointing in roughly the same direction, as if they are all being shepherded by an unseen hand. The mathematical probability of this clustering happening by pure chance is vanishingly small. Something massive, something with a gravitational pull powerful enough to orchestrate these distant dances must be out there. This hypothetical world would be a true giant, likely weighing in at up to 10 times the mass of Earth. It would trace an immensely long and elliptical orbit, swinging from a perihelion, its closest point to the Sun, that is still far beyond Neptune, out to an aphelion that could be more than 600 times farther from the Sun than Earth. A single year on this world could last 10,000 to 20,000 Earth years. Spotting it is a monumental challenge. It would be incredibly faint, reflecting only the barest sliver of sunlight, and its orbital motion would be agonizingly slow. Astronomers are using the world's most powerful telescopes, like Subaru in Hawaii, to conduct a painstaking pixel-by-pixel search of the vast celestial territory where it is predicted to be. They are looking for that one faint point of light shifting imperceptibly against the backdrop of fixed stars. The discovery of Planet 9 would be more than just adding a new world to our charts. It would trigger a revolution in our understanding of the solar system's formation. How did such a giant planet end up in such a distant, tilted orbit? The leading theory suggests it was not born there, but was violently ejected from the inner solar system in its chaotic youth, a dramatic event that reshaped the entire planetary system before it settled into its current arrangement. Finding this cosmic hermit would confirm a lost chapter of planetary violence, revealing that our home system's history is far more dynamic and eventful than we ever believed. Even the most familiar cosmic landmarks can hide breathtaking secrets. The Whirlpool Galaxy, officially known as M51, is one of the most photographed and studied objects in the night sky, a textbook example of a grand design spiral with its elegant arms winding gracefully around a bright core. But what our eyes perceive is only a fraction of the story. When astronomers point radio telescopes at this celestial whirlpool, they see a completely different, far more immense structure emerge. The familiar spiral arms, so brilliant in visible light, are merely the bright inner districts of a much larger metropolis. Faint, sprawling arms of neutral hydrogen gas extend out into the darkness, tracing a ghostly version of the spiral pattern that stretches tens of thousands of light years beyond the visible edge. These are the galaxy's true, full dimensions, a hidden architecture revealed only by the silent whispers of radio waves. This invisible structure is a permanent scar, the lingering evidence of a violent cosmic dance. The Whirlpool Galaxy did not form in isolation. Billions of years ago, a smaller companion galaxy swept past it in a close gravitational encounter. This near collision sent powerful tidal forces rippling through the larger galaxy, like a stone thrown into a pond but on a galactic scale. These forces did not just sculpt the beautiful visible arms we see today. They pulled and stretched the galaxy's outermost reservoir of diffuse hydrogen gas, dragging it out into these vast, faint streamers. The companion galaxy, still visible today, is now connected to M51 by one of these faint bridges of gas, a celestial umbilical cord recording their ancient interaction. This discovery fundamentally changes our understanding of what a galaxy is. We are not looking at a static island of stars, but at a dynamic, evolving entity whose true form is often written in invisible ink. The Whirlpool Galaxy's hidden arms are a fossilized record of its past, a reminder that even the most perfect spiral is the product of chaos, its full story legible only when we learn to see the dark. Our journey ends not with a bang but with a cosmic gasp. There exists a stellar explosion so peculiar that it leaves behind a ghost, a star that survives its own death. This is the type IX supernova, and its remnant is the zombie star. In a typical type Ia supernova, a white dwarf star steals so much material from a companion that it crosses a critical mass threshold. The resulting thermonuclear detonation is so catastrophic it completely unbinds the star, leaving nothing behind but an expanding cloud of stellar debris. It is a total, brilliant self-annihilation, but the type IX event is different. It is a partial explosion, a fizzle. The white dwarf still detonates, but the blast is asymmetrical and weaker. It violently ejects a portion of its mass into space, but fails to completely destroy itself. What remains is a battered, burnt-out stellar corpse, a zombie that continues its existence after experiencing a partial death. This shattered remnant is left behind, a scarred and incredibly hot cinder, often hurtling through space at high speed as a result of the lopsided explosion's kick. The existence of these zombie stars fundamentally challenges our textbook understanding of stellar life cycles. We thought a supernova was a definitive end, a final curtain call. But nature has shown us a third option, a state between life and death. How can a star undergo a thermonuclear explosion and not be utterly vaporized? The mechanics are still hotly debated. Perhaps the explosion only rips through the star's outer layers, leaving the core intact. Or maybe the blast fails to propagate evenly, leaving a chunk of the white dwarf behind. Each zombie star we find is a clue, forcing us to rewrite the rules of stellar suicide and accept a far stranger, more nuanced cosmos than we ever imagined. From the silent echoes of zombie stars to the ghostly pull of the Great Attractor, our journey through 30 cosmic wonders reveals a universe that thrives on the impossible. Each oddity, from the Boötes void to the diamond world of 55 Cancri E, is more than a mere curiosity. It is a crack in the facade of our understanding, a place where the known laws of physics are stretched to their breaking point and our imagination is forced to catch up. These are not just anomalies, they are guideposts pointing toward a deeper, richer, and infinitely more bizarre reality than our textbooks ever described. They teach us that the cosmos is not a static museum, but a living, breathing, and often violent arena of creation and destruction. The next time you find yourself under a clear night sky, remember that you are not just looking at points of light. You are gazing at a canvas filled with phantom galaxies, stellar cannibals, and whispers from other universes. Let that sense of wonder pull you deeper. Tell us in the comments which of these cosmic oddities reshaped your view of reality, and subscribe to continue exploring the profound mysteries that lie just beyond the edge of our understanding.